Notes. So new real number properties. So we're looking at identifying to use the properties of real numbers. So, and we talked about these a little bit already. So hopefully this is a review. Let's work from the bottom up. What are the natural numbers? I kind of combine these two together. Natural and whole numbers. What are they?
0, 1, 2, 3.
Yeah. So the whole numbers include 0, 1, 2, 3. If you want to get real technical, natural numbers are just the counting numbers, not including 0. Okay. What about integers? What do integers then include? What do I need to add to this? Remember, just adding to this. The negatives. So this includes all previous negatives. -3, -2, -1, 0, 1, 2, 3, and so on. Then rational numbers, and again, I'll include all of these, plus what kind of numbers? What is it? Repeating decimals. So something like 3 points. We'll just use 3, 3 repeating. Okay. What else? So repeating decimals. What other kind of decimals? Nope. Not for rational. Fractions. So 7/10.
That's for irrational?
Yep, for rational. And what other kind of?
Is that a 5 or a 3?
3. What other kind of decimals? Repeating.
The decimal is like
Well, it could be. There could be a 0 in front. There could also be numbers in front. Okay. Terminating. Decimals that end. So something like -5.25 or -0.5 or anything that ends. Okay. So repeat. So repeating and terminating. And then all fractions.
Did we do this last week? Something like this?
Well, we talked about this last week.
What about last week?
Irrational numbers then are what?
Never ending like pi.
Yeah, never ending. Okay? So never end
Mr. Felton, dude.
like pi.
I asked you if the last 2 numbers were for irrational, and you said yes.
No, rational.
No.
These are all rational.
But you lied.
Okay? So never ending like pi. Square root of 2.
Yeah. Does not say repeating, Mr. Felton.
If you don't talk and listen,
I
you
want
hear
to
the
see
words.
the ones you not. And we can't see when you're writing either.
All of these numbers fall into real numbers. Okay? So real numbers are everything that is listed down below. All below. And before we talked about imaginary, they're not on here. Okay, but we will get into a little bit of imaginary. Probably second semester. Okay. Okay. Comparing the following numbers. So we're just using our basic symbols. greater than, less than, okay, equal to. So hopefully hopefully a couple of these are pretty easy. 5 and 7. 5 is what? And 7. Less than. Remember, each the big number, points at the small number, however you want to remember it. Okay? You guys probably don't remember Pac-Man. You might remember Pac-Man. Somebody gonna come back. Okay? Pac-Man always eats stuff, right? Yeah. So he wants to eat the bigger number. Alright, number 2. 5 and 7. 5 and negative 7.
That's
5.
gonna eat the 5.
It's going to eat the 5. 5 is greater than negative 7.
Maybe not.
Good. Number 3, negative 5 and negative 7.
It's gonna eat the 5 again.
It's going to eat the 5 again. Okay, be careful with those negatives. Okay? Remember, smaller think about it like money. I'd rather only be at negative 5 in the amount of money I have. I'd rather owe someone $5 instead of $7, right? Okay. Number 4, 5/7 and 7/5. Hopefully this one's pretty easy. 7/5 is what? Yes, 7/5 is bigger, right? Okay, so this is smaller than 1, bigger than 1, right? So hopefully that one's pretty easy. Number 5, negative 8 over 4 and 6 over negative 3. It is equal because both of them equal what? 2. Both equal negative 2. If you simplify. Okay? So sometimes it's easy, sometimes you may have to simplify it. Figure that out. Okay? If one wasn't bigger than 1 and one wasn't smaller than 1, what would I do here? What could I do here to figure out which one's bigger? What'd you say? Oh, okay. Well, what if I had two numbers smaller than 1? How might I compare them? Yeah, convert them into decimal. Okay? So if you need to compare them, easiest way to do that would be convert them into a decimal. How do I do that? Well, how do I make 5/7 a decimal? Just divide it. Okay? 5 divided 7 gives me my decimal. Okay? And then 6 pi and square root of 2. Well, we know what pi value is. What's pi value? Or about 3.14. What about square root of 2 now? So how do I know? How can I figure out what
The
that
square root of 2 is 1.41.
1.41.
Is
Okay.
it never ending?
So it is. Yeah, it keeps on going. So does square root of 2.
So it's gonna eat pi.
So it's going to eat pi. That's it. Okay. Different properties. Okay, so we're going to talk about these different properties. Identity property of addition. Okay, what's identity mean? Yes, what it is. So if I have, give me a number. 7. Let me actually. So if I have 7, what can I add to 7 to get the identity? 7.
0.
0. So anything 0 plus a number equals that number. A number plus 0 equals that number. That's that identity property of addition. Adding something to something else and they get the exact same value. Okay? So again, it's these words here that you need to look at to help you figure out what you're getting. Okay? And you can kind of figure it out if you know what you're looking for based on these words. Identity property of multiplication then. So again, same thing. If I have a number, 15, well 15 times what gives me that identity? 15. In this case it's 1. Right? So algebraically, anything times 1 gives me that value back, right? Or you could put 1 times anything. So you could have 1 times any y equals y. So identity property of addition, adding zeros. Identity property of multiplication, multiplying by 1. Okay? So, commutative property. What's it mean to commute? Go somewhere. Okay? So you all commuted here. Whether it was a bus or a car. Okay? So you moved from wherever you were at. Okay? So if it was me, I moved from my house, I commuted to Buckeye. Okay? So all we're doing is changing location, right? Does that make sense?
Yes.
So if I'm adding is commutative. So if I have 5 plus 3, well that's going to be equal to what? If I move locations, it can be what? 3 plus 5. Those are the same. Okay? Order doesn't matter. Basically that's what it's saying. Order doesn't matter. If I'm adding. So algebraically, you would have variables. X plus y then equals y plus x. You're just changing the order. Okay, you're still adding the same two numbers, you're changing the order. Okay, so same thing here, commutative property of multiplication. Again, it doesn't matter the order I multiply in. If I have 3 times 5, well that's the same as 5 times 3. Okay? So algebraically we have two values, A times B, same as B times A. And again, those can be any variables you want them to be. So commutative, changing the order. Numbers find you.
Huh?
Numbers looking for you.
Oh, the screen down the way.
Last one then is associative. Okay. So associative property. So the associative, what's it mean like to associate? Yeah, who you like talking to. Okay. So example here would be something like if I had, and this is a property of addition, so 7 plus 3 plus 5. Okay? So when I look at this problem, 7's kind of out, right? 3 and 5 are kind of, they're associating with each other. So 3 and 5 are kind of with each other right now. But again, because this is addition, okay, that order doesn't really matter. I can change who I'm associating with. Okay? So, because 7 plus 3 is 10. And then 10 plus 5 is 15. Okay? So that might be a little easier to add than if I had it this way. Okay? Does that make sense? Mm-hmm. So it's what's being grouped together changes a little bit. The numbers didn't change, right? I still have 7, 3, and 5 I'm adding. The only thing that changed is what was grouped together. I didn't write the algebraic. So the algebraic would be A. So A plus B plus C in parentheses. No, wrote it too big. Equals, in parentheses, A plus B plus C. And again, it doesn't really matter what number. I could group 7 and 5 together. Okay. And it had 3 on the outside. So, associative property again, multiplication this time. Okay. So here I may have something like so in parentheses 10 times 4 times 6. Okay. Well, I can change that order and say, well, multiplying by 10 is easy, right? It had a 0 on the end. So maybe I want to say, well, 10, I'm going to pull the 10 out, and I'm going to take 4 times 6. Well, 4 times 6 is 24, times 10 is 240 then. Okay? So changing that order makes it a little easier to multiply that. So the same thing here algebraically. I'm just using, so x times y, and then times z. And again, I can change that order, so x times y, and then grouping y and z together. Okay. So changing who it's grouped with, changing who it's associating with. Distributive property, okay? Distributive property. So, I'm going to show you to you algebraically, because that's typically when we use it, okay? It can be used without just being algebraic, but so if I have something like 2 times x plus 4, okay? So if I have 2 times x plus 4, what does that, and I want to simplify this, so I want to get rid of all the parentheses. What am I doing here?
2 times x, 2 times
Yeah, distributing that. Taking this 2 and multiplying it in to both. So 2 times x, and I get 2x, and then 2 times 4. And I'm going to write it as, so it looks like that. And then we could simplify it as 2x plus 8. Okay? So that's typically when we use this property. Okay? You can use it when there's no variables, but again, most of the time I think it's easier if there's just numbers to solve the parentheses and then multiply on the outside. Okay? So you could have 5 times 4 plus 6, and again I can multiply these together. 5 times 4, 20. 5 times 6, 30. And when I add them, I get 50. Okay? But again, 6 plus 4 is 10. 10 times 5 is 50. I think that's easier if I have numbers. Okay? So really the only time we're going to use this is if it's algebraically. But it still works if it's not. Couple more. Additive inverse. Okay? So we talked about, and you've used the inverse a lot before. Okay? What's the inverse mean? Opposite. So if I have, for example, this is when we've used it. If I have x plus 3 equals 7. Well, how did I solve for x? Yeah, I subtracted 3, right? The inverse of positive 3 is negative 3, right? So this is kind of when we use this property, okay? Basically what you're looking at is, if I have a number, okay, so plus 3 minus 3, it just leaves me with that value in it, okay? So this is that additive inverse. Does that make sense? Gets rid of it. Last one. Okay. Multiplicative inverse. And this is the only one that these two are a little different. Okay? If I have an additive inverse, what does this equal? Well, 3 minus 3 is what? 0. Okay? So, in this case, additive inverse equals 0. Okay? If I have multiplication, so I have 5x equals 65. Okay. How do I solve algebraically here? Yeah, I divide. Okay. Now, dividing by 5 is the same as multiplying by what?
2. 5.
So dividing by 5 is the same as doing what? Multiplying by that reciprocal. Okay? So dividing by 5, and again, in this case, this multiplicative inverse equals what? 5 divided by 5 is what? 1. So in this case, these equal 1. Okay? 1/5 times 5 is 1. So additive inverse equals 0. Okay? Multiplicative inverse equals 1. Okay? All the other ones are pretty much the same. This is the only one that kind of changes between adding and multiplying of what the result is. Okay? But let's do this. You can add this down below. So I'll give you a minute to write that down. Okay. Simplifying. Here's how we can use these different properties we talked about. Okay. I have parentheses. I need to simplify. Can I combine anything inside these parentheses? No. Because x's and y's can't combine. Anything with a variable can't combine with a constant. Okay? So, what can we do? Well, we can use that distributive property. Okay? So, there's like an imaginary 1 here. Okay? And we can take that negative 1 and we can distribute it in. Okay? So 3x plus 4y, negative 1 times a negative 5x gives me a positive 5x. Negative 1 times 8y, positive is a negative 8y. And a negative 1 times a 2 is a positive 2. Okay? Now that we have all addition, or subtraction, which is the same as addition, right? Now we can use, and we don't typically do this, but we can use the commutative property. Okay? We can change the order. And that's what I do whenever I'm simplifying these. Usually we don't write it out. I'm going to write it out this time. So I can take all my x's and move them to the front. 3x plus 5x. Right? All my x's.
Why can't we just combine them together?
You can. But this is the idea. Okay? So this is that community product. 4y minus 8y. And then 2 on the end. And then I'm looking at combining these. Okay? So when we combine like terms, what property are we using? Commutative property. Okay? Typically we just don't write it out. We write it out. Okay? Because it's just more work. So 3 plus 5 is 8x. 4y minus 8y is negative 4y. And then our 2. And then we're simplifying. Okay? So we will use these, and you have used them already. Okay? When we distribute, when we combine like terms, all of that is those properties.